In the second video, I will show you how to generate mesh for next CFD simulation in OpenFOAM. We'll be using FreeCAD for generation of domains, and we will be using Salome software. It's open source software for generation the mesh. Okay, let's start with generation domain part for CFD simulation. Okay, let's open last Propeller project. I called it Propeller. It was a last step of creation of Propeller in previous video tutorial part 1. You can find it on my channel. It will be the previous video. Okay, so when we have this 3D model, we have to create the CFD domain of this Propeller, internal domain, and second one will be the external domain. I will be used for this the cylinders. So let's go to part Workbench, and in part Workbench we have to create the cylinder. Yeah, if we will hide it, you can see this cylinder. It's small cylinder. Let's increase it. Let's set, I think, 100 millimeters. It will be something like the dimension of this propeller, and we have to set the height. It will be also 100. Okay, I think we have to increase this external part of CFD domain, because here we have the very small gap. So let's increase it. I think 150 will be enough, and height will be 100. So let's change a view and add some transparency for cylinder. Go to the view and let's set here 70. Okay, and how can you see? We have the not right position of this cylinder. We have to change this position in this Z direction to negative value. And now let's open the position for this cylinder in 3 and change that position -50. It will be something like center of this cylinder. Okay, after that let's copy this cylinder and create the external very big cylinder. It will be something like water domain. But this first cylinder is small cylinder. It will be the internal domain of water, where we will be set a rotation of our propeller. So let's copy it. Click here and set copy. Here, paste. Ctrl C, Ctrl V. You can use it. Okay, and here let's set the big value of radius. I think 500 will be enough for external, and set here I think something like 700. Okay, and now for position in that direction we have to set something like the average, the middle position here, and let's set this half of all 700 millimeters of length, the cylinder. Okay, now we have to create some CFD domains. So let's use this cylinder and choose the control button on keyboard. Let's choose this cylinder and this propeller, and for this let's create the cut operation, and you will get the first cut. It will be the CFD domain of propeller, internal domain, and the second part let's choose this external cylinder and this cylinder internal. You can choose it in the tree, and from the external we have to delete the internal cylinder. After that, let's choose the cut operation, and if you will hide this first cylinder, you will get the external cylinder without propeller. So these two different bodies we have to save to different files in step format and import it to Salome. So let's choose the first internal cylinder and click export, and here let's call it something like, let's repeat it, and I will rename it to internal domain, and save it. Choose the second one and click export and called it external domain. Save it also. Go to this folder, and where we have saved the step files, delete this one because it's not correct name, and let's open the Salome software. You can download it from official site salomeplatform.com. Okay, and let's run it. The Salome is available for Windows and Linux systems. You can install it or download the portable version of the software. Okay, so after that, when we have opened the Salome, let's go to Geometry Workbench. And in this Geometry Workbench, we have to import the internal domain with Propeller. Okay, let's go to our folder, main Propeller form Salome mesh, and let's use the internal domain. Open it and take into account the units. Let's convert it to meters because in FreeCAD we have the millimeters, and click yes. You will get here the geometry in meters. Okay, after when we have here the geometry, let's create the boundaries for CFD simulation. It will be the interface of these surfaces, which we have to connect it with external cylinder using the interface, because the internal domain will have rotation. Okay, so let's create groups. Choose the surface here mode, and let's add this one surface, this, and this. It will be the three different surfaces, and called it ME1. Click apply, and after that let's hide these selected faces here, and let's choose in box with left mouse button all faces and click add. Here you will get very much number of surfaces here, and let's call it like wall. And for this wall of Propeller, we will perform calculation of Turkey. It will be it's called also moment, and after that we will calculate the power on this propeller. Okay, and also we can calculate the thrust. It's a force in that direction here. Okay, so let's click apply and close. And if you will activate this view, you can find the geometry of surfaces. You choose it correctly, and after that let's hide it all and go to Mesh Workbench. Here we will create the meshes for this. Let's go to Create Mesh icon, and for this geometry of CAD geometry, let's create this 3D parameters. Let's set it like 0, 1. It will be maybe 2. It will be 20 millimeters, and here let's set something like 002. It will be the 2 millimeters, the minimum size of volume and maximum size of volume element. Let's try these parameters for mesh generation, and let's go to 2D. After that, let's go to triangle Mephisto. I will use this, and let's lens from edges. Okay, it doesn't have the some settings for 2D geometry. It will perform the triangle operation on surfaces. Use the 1D wire discretization edges. So let's use this. Go to the 1D and let's set the adaptive. And here let's set also, for example, the minimum will be 001, for example, and maximum 0 to be 20 millimeters and 1 millimeters. Click OK, and now we have the all we need for creation the 3D mesh. Let's go here. You have here the groups of faces. It will create the mesh on these external faces on the surfaces and record it. We will be using these names for boundary setup in OpenFOAM in future. So let's go to the mesh and click compute. So let's wait some time. And when mesh generation was performed, we have some report of mesh info, and now we have some number of volumes here, elements. We have this number of elements. It's not very big, but it requires some time for simulation in future. We can reduce or increase this number of elements, changing the mesh parameters, but I recommend you use this value for this simulation. Okay, let's check how looks the mesh on surfaces. Let's hide it and let's check the mesh on Propeller. And how can you see the leading edge and trailing edge? It looks nice, and the mesh on the surface looks also not bad. Okay, let's hide this and this, and we can make a split and to see how looks mesh internal mesh here. Let's make the clipping. Let's choose new absolute and choose a plane. We can use the XY plane, YZ plane. For example, let's create apply and close, and you will get something like clip. How looks internal mesh elements here. How can you see? We have some smooth mesh on surface of Propeller. It's right, And for external mesh we have some rough elements here. Okay, so let's save this mesh. Let's export this mesh to UNV format. This format we will be using for convert the mesh to native OpenFOAM format of a mesh. Let's call it internal mesh. Save it in folder with our step files, and after that let's save this project. If we want, for example, to change some parameters of a mesh and recalculate the results of OpenFOAM, we can use this project, change the parameters, for example, save a new mesh and perform the simulation again. So let's click save and save internal domain project. Save it, and let's create a new document here, and let's repeat the previous steps for external cylinder, and let's create the mesh for external cylinder. Let's import the step file, external domain. Let's click yes also here, and here we have to set some boundaries here. Let's make the create group. Let's call it will be the open. We will be using not inlet and outlet boundaries. We will be using the open condition for these sites. It means that we have the stationary position of a propeller in that direction. Okay, this is our suggestions for simulation, that we doesn't have something relative velocity of propeller in that direction. We have the stationary position in that direction here. Okay, so let's call it like maybe inlet, but if we will call it inlet, we can define how we will look in direction of a flow which we prepare with our suggestions, because we can have the flow to this direction, or negative that direction, or positive that direction. If we will rotate the impeller in different rotation speed, positive or negative rotation speed, if we will set up it in OpenFOAM, you will get the different flow direction. Okay, so let's choose this and call it like inlet. Choose the second, called it outlet. Sorry, we have to add the surface here, and we will get the inlet and outlet. And for the external, we can choose it here, add, and call it, for example, something like external, and apply and close. We have this external part, this outlet and this inlet domains here, but also we have to define the interface between external and internal cylinders domain. So let's go to group, edit group, but no, sorry, not edit group, create group, and choose this surface, height selected, shape, but I don't know what's happened because I'll choose close it, maybe try again. Okay, let's go here, let's create group, main shape, we have to choose it here, okay, and after that we have to hide selected, yeah, it works, hide it and this, and we have to choose this all surfaces, we have to edit, choose it, choose this surface and choose this surface, click add, you will add the 3 surfaces here, click apply, close, and you will get this small cylinder here, it will be the ME2, called it like ME2 interface, okay. And after that, let's go to mesh model and let's create the mesh for this cut 002 geometry. Create mesh. Let's set here the 3D parameters and let's max element volume, but I want to use again 3D parameters here, where we can define, for example, the 10, I think the maximum size will be something like 50 millimeters, and the smallest will be 20 millimeters. Click OK, and here we will just simple NetGen 1D 2D algorithm. Go to the 2D parameters. We don't use this Mephisto because we have the very simple geometry. We can use NetGen 1D 2D. Mephisto can to create the mesh on the difficult geometry, I think, without some it does not require much time for generation on surfaces. If we have something like leading edge, trailing edge, and small edges, we cannot use the NetGen algorithm. It requires very much time for generation mesh, but we can, but it requires much time. Okay, so let's set 2D parameters. It will be 0, 0, 20, 0, maximum size will be 50, also like in 3D, and I want to set the local sizes on face. I want to use this ME, and here I want to use the value of mesh like in ME1 in internal, because if we will have similar number of elements on interfaces, it will we will get less interpolation loss between these two domains in process of CFD simulation. Okay, let's set 20 millimeters here, click OK, and click apply. Let's try to create mesh, and we will get something like 30,003 number of volume elements here, and let's check like looks our parts here. Let's hide this all mesh and let's just to check boundaries. Here we have the small elements, but for external we have the big 50 millimeters elements. Here we have the 20. Okay, so it looks interesting, it looks correctly, and let's save it. Let's perform the export in UNV file and call it like external mesh. Save it like UNV file and save the project if you want to change the some mesh parameters in future. Save it, save project, and let's close the Salome. Okay, thank you for watching. In the next video tutorial I will show you how to perform the simulation and find the moment power on propeller, and like find the thrust on propeller. This is a main performance parameters. Okay, thank you for watching. Subscribe to the channel. Goodbye.